So we have written our first FunC contract. Congratulations. We know that it successfully compiles. What's next? In this lesson, we will learn how to make sure that our contracts code is actually working as expected. So let me remind you our expectations to the code. So our contract is supposed to save a sender address every time it receives a message, and it should return the latest sender address once we call the getter method. Great, but how to ensure that it is working? So we could deploy it to the blockchain, which will be eventually, we'll do this very soon in the next lesson, but Ton has some tools that allow us to simulate some behaviors of the blockchain locally. So this is done with help of Sandbox. The library allows you to emulate the arbitrary Ton smart contracts, send messages to them, and run get methods on them, as if they were deployed on a real network. Because we are having our TypeScript laboratory, we can create a sequence of tests with help of another library called Jest that is used for testing. And this way, we have a test suite that simulates all the important behaviors, and it checks the results. And this is done in sequence. And this is the best approach to write, debug, and fully test your contract before launching them to the network. So first of all, assuming that you are currently in the root of our project, let's install Sandbox, types for it, and Jest. TypeScript part of Jest, and then types for Jest, Ton, and I think Ton is a library that we might already have installed before. No, we will need this. We need to install it now. 1 second. Yes. So we will also need to create a Jest config.js file. So it would point to the preset that is going to be used. So Jest config.js. Great. These contents, we set preset, test environment. And now let's create a new folder in the root of our project. This is going to be a folder called tests. And inside of it, we'll create a file main spec.ts. So this is a standard way to call files with tests. So let's see what, so we have nothing now in this file, but we can see some very simple test code, main FunC contract test. So this is a block, and then this is like actual test that we should write now. So in case you've never written TypeScript tests, you should definitely try this approach. While programming Ton smart contracts, you are going to spend a lot of time, more than half of your time writing tests. And remember this example of our space satellite. So same here, we simulate every important case before we ever deploy the contract to the testnet or mainnet. So we can even try now to actually run yarn Jest, or even just Jest. Yeah, it should be with yarn. And we can see that for some reason our code didn't test. So yes, we didn't save the file. It has to at least have one test. And now we can see the test passed. So, so let's immediately create another script in our package.json. So we would have a shortcut way to run tests. So we will call it test. And it would run yarn jest command. So just like this, I will go with yarn test. It will trigger the jest, and that's it. So in order to write our first test for contracts, we need to understand how we can create TypeScript instance of our compiled contract with help of Sandbox. So as we discussed before, that our contract code is stored as a cell after being compiled. And in our main, in our build folder, main compiled JSON, we have a hex representation of this cell. So let's import it into our file. And we'll also import the tone core, the cell type from the tone core library. So it will look like this. So we import cell, we import our compiled contract. And now to restore our hex and get a real cell, we will use the command from BOC, and you already talked about it on the compilation. So again, we will need to understand, we'll need to use buffer again. So let's have a look how we actually, how this would look like, this code cell that we will import. So it would be like this. So basically, we take a cell class, we run method from BOC, and we provide a buffer that is actually reading this compiled contract that we imported. So let's now actually get started with Sandbox. So you can see in Sandbox documentation that in order to get instance of a contract, you first need to get an instance of a blockchain, local blockchain. So we can also import the blockchain class from the Tone Community Sandbox. And we will see what kind of functions will allow us to actually create the instance of blockchain. We have a method create. So we now have an instance of blockchain locally. So now let's get ready to get an instance of contract, so we would be able to interact with it. So Sandbox documentation is telling us that the recommended way to interact with contract is by writing wrappers. So you would actually use the contract interface imported from Tone Core library, and you would create wrappers that would actually help you to construct it and interact with it. So what does it mean for us? We will create one more folder called wrappers. And inside of it, we will create a file called main contract TS. We use this word main just because we started like this, like we call this contract main, but the name in here is not that important. So make sure you run this command sequence. So now let's open the main contract file for editing, and let's import a new type. We'll import a new type contract. So another thing we will need to do is we need to actually state that this class main contract is actually implementing the contract type. So if you take a look in the contents of the contract interface, you can see that it is accepting like address, init. Init is like init state, which is a combine of code and data, and some other parameters that we're not going to talk about in this lesson. So basically, if you have no idea what this implement means and stuff like this, this has to do with object-oriented programming, and FunC doesn't require this, but we're using this for actually better testing flows with TypeScript. And maybe you should just learn basic concepts of object-oriented programming for this, because if, for example, you can see here, like we will use constructor now, for example. And constructor, this concept has nothing to do with FunC or Tone, but you actually want to understand this in case you will program more. So I'm going to import address from Tone Core. Also, I'm going to import type cell from Tone Core, and now our code is good. So the init property is very interesting. It has an initial state of our contract. So code is obviously the code of the contract, and data, it's even more interesting because remember that we're talking about the persistent C4 storage of our contract. And with this data cell that we pass here, we can actually define what is going to be in this storage once our contract first time executes. So like both of these values have cell type, and they are stored in the memory of TVM. when it's executed. And same code and data cells are also used to calculate the future address of our contract, like we talked about this before. So note that we also imported classes address and cell because TONCore library basically stores those primitives. And now let's define a static method for our main contract. We will call it create from config. So we're not going to use any config parameters for now, but in the future, we might want to actually kind of provide a config file before we even initiate the contract. So we would need to import begin cell from TONCore as well. And another cool thing is we can actually import from TONCore, it's called contract address, this function. So our create from config is accepting a config, ignore for now. It accepts code, which is a cell with the compiled code of our contract, and also work chain. Currently, there's only one work chain. We'll use the default parameter 0. So to better understand this code, let's start from the results we return from the end. So we are creating a new instance of our class, and as defined in its constructor, we have to pass the contract future address and the init state. So that's actually the constructor. And the init state is simply an object with code and data, and code is passed into a method, and data is just an empty cell for now. We are not accepting it from the create from config. So to sum up, it's accepting config, for now ignoring, and in return, we give an instance of the contract to actually start interacting with it with a sandbox. So let's get back to the main, I will close these files. Let's get back to main spec TypeScript, TS, and we'll do following steps. We'll import our wrapper. We're going to import the contract's compiled code, and we already have it imported. And we'll transform it into cell, almost done. And we're going to use sandbox command open contract along with our new wrapper. So we will actually open the contract for interacting with it. So we basically have to also import, just like I mentioned. Yes. So basically, we use a command open contract on the blockchain to provide it with a contract that we create from config. You can see that I'm not passing any config for now, just an empty object, but I'm passing the code cell that we actually import from here. So now we need to start interacting with the contract. So TONCore library provides us with cool construction called address. And as you know, every entity in TON blockchain has an address. So in real life, if you want to send a message from one contract to another contract, you know both addresses. But while writing tests, we emulate contract, and when we interact with the address of our emulated contract is known. However, if we need to send some message to it, we would kind of need to create a wallet. And in Sandbox, you would need to use that such thing as treasury. It's a method on the blockchain instance, and you actually can just do it like this. So it would be like sender wallet. You see this treasury method. All you need to do, you would need to pass the seed. So basically, seed is like a seed phrase. If you like, you could have this whatever you want, but every time with different seed phrase, the address of this wallet would change. So let's think more about the test. Since we have an instance of our contract, let's send an internal message to it. So our sender address will be saving. It will be saved in the C4 storage, in the persistent storage. So we remember that to interact with our contract instance, we need to use the wrapper. So we would go back to the wrappers file, and we would actually create a new method here in our wrapper that would be called send internal message. So our new method is receiving parameter of type contract provider, the sender, and value, how much money should be sent with it. So normally we don't worry about passing contract provider because it will be passed under the hood as part of the contract instance. But don't forget to import those. Yeah, we need to really import those types from the library. Yes. Great. And let's implement this logic of sending the internal message. This provider that is passed under the hood, it has the method internal. And we're passing the sender, so we get it here. And we would actually need to also update input from Tone Core to get this enum, which would set the send mode. You will learn more about send modes. So we use one from here, but if you would know the number, you would actually you could choose and read more about what kind of send modes are here, and you can learn about send modes in documentation. And also, basically, what do we kind of pass with internal message besides sender? It's also value, so the amount of coins, and the body of message is important one. For now, we only just pass an empty cell, but here we could put more and more information later on. So our final code, would look like this. So we have create from config method, we have send internal message method, and we would actually now get back to the test file, and we would actually run this, or we would run the method we just created, send internal message, and we would use the function getSender to actually kind of get the instance of sender of the treasury. So basically, from this, we could get an address later on. We will also need to import the toNano function. And this function helps us to convert some string into the big num type of the values, because like 1 ton, it consists of 1 billion of grams. So basically, we would need to convert it into this big int type. So for example, this 0.05, it would become, so 1 ton is 9 zeros, and we would basically want to, this would be 5 millions. This would be 5 millions of, actually, I guess 50. Yes, 50 millions of grams, but this is just a small things that you will get used to it very quickly. So let's move to the invoking getter method. So we are able to actually get the data, but we will need a new wrapper. We'll need a new method on our wrapper. So we will call it getData. Again, we get provider passed into it. So basically, we are having this stack as a tuple reader type, and it's getting all the results of the running this getter method. And you could play around with it to console it, but we know that it returns slice, and this stack provides us with a reader called read address. So basically, you know that once you return this data, you have to read out every part of it. So here we get the reader, we get the address of the sender, and we call it recent sender in this object, and we return it when someone is calling this method. So we have done all the preparations, and now we will write actual test logic. Here's how our test scenario is going to look like. So first, we send an internal message. We ensure the send was successful. we call a getter method of the contract, and we ensure that the call was successful, and we actually compare the results that we received from getter. So we would need to compare the address from where we actually sent it and the results that we get from the storage once we run the getter method. Seems quite simple and doable. So important thing we need to actually install in our project is something that Sandbox team developed. It's an amazing thing. So they equipped us with TestUtil. So we will now, after we install TestUtil from Ton community again, we will actually be able to use custom jest matchers. So, for example, we have a matcher to have transaction. It means that once we send internal message, we can check that our contract has certain transactions, and that's exactly how we're going to do the actual test. So let me create one example for you. So after we send internal message, we would actually save the result of it like this. Yeah, send message result. And we would actually expect its transactions. Yes, we would need to await because this is async function. We would be able to access the transactions after this message. And we need to import the TestUtils. We need to import TestUtils, so our matcher for jest would be possible to use. So basically, we send message from sender to contract, and we expect it to be successful message. So we expect this transaction to be successful, and then we run the getData method that is actually accessing the getter method, and we would expect the most recent sender to be the same address as the sender wallet we actually just initiated here. So, and now we are actually ready to run tests. So we can do yarn test script, and we would expect our transaction to be executed on the local chain example, and we see that test actually passed. So we will also rename the name of the test, so it would make sense. So it should get proper most recent sender address. And it is that simple. Let's check that we actually have this test script, but one cool thing I would suggest to us to do, it would be creating a, like in this lifecycle, you would want to compile the contract before you actually run the test, because you change something in contract, then you run tests, and it kind of pre-compiles it. So yes, it's that simple, and at this point, we are ready to deploy contract on-chain in the next lesson.